After completing this lesson, you will be able to use adaptive cutting strategies to clear material from one side, derive tool paths to create new ones using similar settings, and duplicate the setup and the tool paths to program cutting the opposite side of the car. For this lesson, you can continue using the model from the previous lesson, or you can open the F1 Car CAM Setup Fusion Archive file using Create New Design from File. Now that I have my setup, I'm ready to start generating toolpaths. Because of the type of geometry that I have, I want to use a 3D adaptive clearing toolpath. Now you might choose to not create a roughing toolpath and a finishing toolpath. We'll be doing this as an example of how to generate these toolpaths. So I'll start the 3D adaptive clearing. There's multiple tabs. The first thing I'll do is go to select a tool. There's a large library of tools built into Fusion 360 from various vendors, but I want to import tools from an existing tool library. This library was included with the data sets for this course. When I click Open, I'll see that this tool library only has one tool in it. It's a 1/4-inch ball end mill. I'll click OK, and has all of the speeds and feeds information included in the library. Then I'll want to make sure to shut off coolant. I'll go to Geometry. I want to use a machining boundary. I'll use the bounding box. And I want to make sure that the tool is going outside of the boundary, that it can drop down next to the model. I'll shut off Rest Machining since this is the first toolpath, and I'll go to the Heights tab. Since this is a symmetrical model, I want to take advantage of a few different things. For example, setting the bottom height. You can easily click and drag the bottom height, but instead, I'll say that the bottom height is based on the stock top minus 37 millimeters. This will allow the tool to drop down past the center line and cut the silhouette of the part properly. Next, I'll go to the Passes tab. The Passes tab is where we control how the tool will be engaged while cutting. The optimal load right now, if I look at the expression, is set to the tool diameter times 0.4. That's good. But I'll set the maximum roughing step down to 37 millimeters, thus allowing the tool to go all the way down and start cutting along its face. I'll leave stock to leave engaged, but reduce the amount of stock to leave down to 0.3 of a millimeter for axial and radial stock. Finally, I'll go to the Linking tab. Linking controls the motion between cuts. I'll tell it that I want to use minimal retraction, and I'll tell it that I want to use more stay down, if at all possible. If it needs to go into the material, I'll allow it to plunge, and I'll say OK to generate the toolpath. After a few seconds, we're able to see the toolpath that was defined. We'll see that it's cutting on multiple levels, and it looks like it's going well beyond the midplane of the part. Now what I'd like to do is right-click on the adaptive clearing toolpath and say Create a derived operation, and in this case, select Parallel. So Parallel is a finishing strategy, but it will adopt things like the tool, the coolant being disabled. It will adopt the geometry that will allow it additional offset of 3.2 millimeters to go outside of the edge. For heights, we'll leave that. Passes, I want to set the direction of the pass at 90 degrees. The direction is established by X. So 0 degrees would run the length of the part. 90 degrees will run across it. And I'm going to set the step over to 1 millimeter. All of these values might be different for your car, for the type of machine, and for the type of tool you're using. What we're doing here is just exploring some of the options. On the Linking tab, we'll leave that be and click OK. We can see what it's selected. I did miss one additional thing. See how it's machining over the portion of the model that will be left and thus getting close to the fixture? Let's edit one more time. Go back to the Geometry tab, turn on my Avoid Surfaces, and select the solid model that's virtually attached to our car body. I'll click OK and let it regenerate the toolpaths again. And you can see now it's avoiding cutting any of those surfaces. So these two toolpaths look pretty good. So what we can do now to save a lot of energy is right-click on the setup and select Duplicate from the menu. And then edit the setup. We can rename it to right side. Now let's edit the right side setup. The first thing we need to do is start to picture what's going to be happening with our model. I'll turn off the milling fixture just to get a little more clarity. So this side is already machined. What we need to do is flip our model over and machine this side. Since the origin doesn't need to change, we only need to change the direction of the Z-axis. To do this, select the arrowhead on the Z-axis. The X and the Y will remain in the correct orientation, so we're finished changing the coordinate system. I'll go to the Post-Process tab, change the program number and name, and change the coordinate system. Click OK, and our setup is complete, but our toolpaths have failed. All we need to do is generate the toolpaths again, and now we'll have the toolpaths for this side. To test this, I'll turn off the standard block, I'll set the setups at the top level, and select Simulate. We'll set the toolpath to only show the tail. I want to see the stock. The Info tab will show me the information on the tool as far as what it's doing at any given time. And I can see the statistics that say it will take 16 minutes with a machining distance of 61 meters and 4 operations to cut this part. If I click play, it will begin the process of machining my part. We can speed it up. We can skip to the next operation and skip directly to the end of the process. The graphics that are generated will show us the approximate surface finish of the part and allow us to validate that we're getting the results we were looking for.